Hello there, Mr. Sutton here with the IM372 Part 2 homework solutions on special right triangles, specifically the 30-60-90 triangle. For this problem, we're told that a 7-foot ladder leans against a wall and makes an angle of 60 with the ground. We want to know how high up the wall the ladder reaches. Well, let's draw a picture to represent this. If we have a ladder against a wall, that ladder and the wall and the ground form a triangle, specifically a right triangle, assuming that the wall is coming straight out of the ground and isn't crooked or anything. So let's label our triangle with a few dimensions here. They said it was a 7-foot ladder. The ladder is this hypotenuse leaning against the wall, so this is a 7 for that length. And they said that it made an angle of 60 degrees with the ground. So the ladder and the ground meet right here, so this is 60 degrees down here. And they want to know how high up the wall the ladder reaches, so they're looking for this height of the triangle, which I'll just call x. So we're basically solving for x. Now, since we only have one side of this right triangle, we can't use Pythagorean theorem, so it's probably a special triangle kind of problem. And if you look, 90 minus the 60 degrees we already have here gives us another 30 degrees for this missing angle. So this does turn out to be a 30, 60, 90 right triangle. And we know that the sides of those triangles are in the ratio of s, s radical 3, and 2s. Let's go ahead and label this triangle with those different ratios and see if that helps. So s is always across from 30 degrees, so that's down here, that's the ground. And then s radical 3 is across from 60, so x is going to be equivalent to s radical 3. So if we find the value of s, we can plug it in here, and that'll give us the x value. And then finally, 2s, that's across from 90 degrees. It looks like 2s is equivalent to the 7 that they gave us. So we can actually write the equation 2s equals 7. And then solving for s by dividing by 2, we get s equals 7 over 2 or 3.5, whichever you prefer. Although if you look at the answer choices, it looks like they left it in fraction form. So I'm going to do the same just so I get that type of answer. Now going back to x, because that's what we're trying to solve for here. It looks like x equals s radical 3. Well, we just found the value of s. It's 7 over 2. So plugging that in for s here, we can say 7 over 2 times radical 3, or just 7 radical 3 over 2. And that's in feet, and that is going to give us answer choice B. For this problem, we have a diagram with a right triangle and some measurements. We notice here that we have a right angle, and only one side is given, so we're going to need something other than Pythagorean theorem here. So we want to know h, the height, in meters of our triangle. Well, I've got 30 degrees right here. 90 minus 30 gives me 60 for this other non-right angle, and this means I actually have a 30, 60, 90 triangle. Well, the sides are in the ratio of s to s radical 3 to 2s for every 30, 60, 90 triangle. So let me label the different sides of this, and we'll see if that'll help us figure out the value of h. So s is going to be across from 30 degrees, and then across from 60 degrees we have s radical 3, although it doesn't look like that's really involved in the problem a whole lot. And now our hypotenuse, aside from 90, is going to be 2s. The only number they actually gave us on this triangle was this 18 meters for the hypotenuse. That equals this 2s here. Whatever 2s is, it has to have a value of 18. So solving for s then, because that'll help us find the value of h, divide by 2, we get s equals 9. And now we go back here and we see that h actually equals s. It's the same as s. So that means that h has a value of 9. And because this is a real-life problem with units here, that's going to be 9 meters. To solve this triangle for the missing sides, we notice that it's a right triangle with only one side given, so we can't use Pythagorean theorem. But since this is 60 degrees here, this must be 30 degrees over here. 90 minus 60 is 30. So this is actually a 30, 60, 90 triangle. It's a special right triangle. And the ratio of the sides on these is always going to be s, s radical 3, and 2s. Labeling those on the triangle, this s side is always across from the 30 degree angle, so that's over here on the right. S radical 3 is across from 60 degrees, up here on top. And then the 2s is across from the right angle, so that's down here on the hypotenuse. The only constant they gave us, the only side they gave us, was this 8 right here. And as luck would have it, that happens to correspond to the s that we just wrote. That means that s equals 8. And now that we know the value of s, we can actually plug it back into these expressions to find u and v. Let's go alphabetically, starting with u. So that's going to be equivalent to 2s. Now, since we just found that s equals 8, u is going to be 2 times 8, which means u is going to be 16. And then we see here that v corresponds with s radical 3. So that means v must be 8 radical 3. For this problem, we're given a right triangle and one side. We're trying to find the other two sides. Because we can't use Pythagorean theorem, let's see if we can use special right triangles. If this is 60 degrees here, this is 30 degrees up here. So this is a 30, 60, 90 triangle whose sides are going to be in the ratio of s radical 3, and 2s. Labeling those on the triangle, s always goes across from 30, s root 3 goes across from 60, and then 2s is always the hypotenuse. So out of all these three sides, the only one we actually have is this 5 radical 3. That corresponds to s radical 3. So as an equation, we can write s radical 3 equals 5 radical 3. And this is pretty convenient because to solve for s, we just divide by root 3, which basically cancels out the root 3's, leaving us with s equals 5. Now that we found s, we can plug it back in to find the sides that we were actually looking for. So just going in alphabetical order, we see that x equals 2s. Since s is 5, that means x is 2 times 5, so x is 10. And then y we see is the same value as s, so that means y is 5. On this problem, we're trying to find x and y. To do that, since we only have one side of a right triangle, we can't use Pythagorean theorem. Let's see if we have a special right triangle here. If this is 60 degrees, that means 90 minus 60 is 30 degrees over there. So this is a 30, 60, 90 triangle. And that means the sides are in the ratio of s radical 3, and 2s. For the s side, that's always across from 30. So that's going to be this side down here. S radical 3 is across from 60, so that's over here. And 2s is the hypotenuse always, so that's up here. The only one of these values we have is the hypotenuse. They said that was 15. So 2s and 15 are the same. So then to solve for s, I just have to divide by 2, giving me 15 over 2. Now that I've got s, let me plug that back in to get x and y. We'll go alphabetically. So let's find x first. That equals s radical 3. And since we just found s was 15 over 2, that means that x is going to be 15 radical 3 over 2. Now for y, y actually equals s, so y is just 15 over 2. For this problem, we have a 24-foot ladder placed against a building to form a triangle, so let's draw a triangle, with the sides of the building and the ground. If the angle between the ladder and the ground is 60 degrees, how far is the bottom of the ladder to the base of the building? So let's put in some dimensions here. We have a 24-foot ladder. That's this hypotenuse here that's laying from the ground to the wall. So we'll put a 24 here. And they said the angle between the ladder and the ground was 60. That's this angle right here, so that's 60 degrees. They want to know how far the bottom of the ladder is to the base of the building. Well, from the bottom of the ladder right here to the base of the building, we're talking about this bottom side of the triangle. And they didn't say it was a right triangle, but it probably is if you're talking about a wall coming out of the ground, unless this building's crooked, which we'll assume the wall goes straight up and there's no structural defects. So we're basically trying to find this side. We only have one side of a right triangle. So this is a good task for special right triangles if we have one. Now, since we've got 60 degrees here, 90 minus 60 gives us 30 for this other angle. So this is indeed a 30, 60, 90 triangle. The sides then are in the ratio s radical 3, and 2s. So let's label those on this triangle. S is going to be across from 30, so that's down here, equivalent to x. S radical 3 is across from 60. That's over here, and that doesn't really correspond to much in this problem other than the height above the ground of the ladder, but they're not asking about that. 2s, the hypotenuse, goes over here. That's always across from 90 degrees. And now they told us the hypotenuse was 24. So that means that 2s equals 24. And that's important because we're trying to find s. So this gives us an equation we can use for that. Dividing by 2, we see that s equals 12. And now that I have s, let me plug that in to get the value of x, which is what we were looking for down here. Well, we see that x and s are really the same thing. And since s is 12, that means x is 12. So that means that it's 12 feet from the ladder to the building, which gives us choice C. For this problem, we have a diagram with a 20-foot ladder that's 10 feet away from a wall. And basically, we're trying to find this angle here between the ladder and the wall. So the key on this one, without using any kind of fancy SOHCAHTOA trigonometry, is recognizing that there's a certain ratio to these sides. And they only gave us 2 of them, so it's kind of hard to see. But we can think of this side down here as being maybe an S. And then this hypotenuse here is a 2S. And then, if you were to use Pythagorean theorem to figure out this third side, 2s squared, that's 4s squared minus s squared would be 3s squared. Square rooting that would give us s radical 3. So whenever we have this ratio, this s to s root 3 to 2s ratio, this is actually the ratio of a 30, 60, 90 triangle. So that's what this triangle is. And we can pretty safely conclude that x is not 90, because here's 90 degrees. So that means that x is either 30 or 60, both of which are answer choices. So which one is it? Well, the s expression on these is always going to be across from the 30 side. That's why we write the ratio and the angles in the order that we do. They always line up with whatever their placement is in this order. So that means that this angle across from s can only be 30 degrees. So that ends up giving us answer choice B. On this free response problem, we have Sanjeev and Nancy taking an evening class at a university, and we've got a nice little map here. Here's Nancy's house down here, here's Sanjeev's house, and Sanjeev has an office as well. So in the morning, Sanjeev drives from his house to his office, and who knows how he gets to the university. We haven't gotten there yet. All right, so based on the measurements in this diagram, and the only measurement they gave us was it's 12 miles from Sanjeev's house to the university and 8 radical 3 miles from Sanjeev's house to Nancy's house. Based off of all this, we want to know the distance between Sanjeev's house and his office. So I'm going to put a little x here to represent the value that we're looking for. Now, the key on this is recognizing that this is a leg on a right triangle, but not just any right triangle. This triangle, we have 60 degrees here, so that means there's 30 up here. This is a 30, 60, 90 triangle. And that's important because we only have one measurement on that triangle. So if you want to find a side of a right triangle with only one measurement, you can't do it with Pythagorean theorem. Got to use either special right triangles or some other kind of trigonometry. So let's label our triangle. We've got the ratio of s radical 3, and 2s. So the s side is always across from 30 degrees. That's this x that we're actually looking for. So if we find s, we've actually found x as well. S radical 3 is across from 60 degrees. That's this distance here between Sanjeev's office and the university. I'm not really sure we need that for this problem, but I'll put it up there anyway. And then 2s, that's always going to be across from 90, so the hypotenuse. That is this 12 miles from Sanjeev's house to the university. So to get s, we need to set one of these expressions equal to an actual number. The only number we have on this triangle is this 12 miles. So we can say that 2s equals 12. So then dividing by 2, we get s equals 6. Now backtracking a little bit, x is the same thing as s. So that means that x equals 6 miles. So 6 miles from Sanjeev's house to his office. So for this part, I'm going to keep the diagram markings up that I had in part A, because I think they'll be helpful for this part too. Based on the measurements in the diagram, what's the distance to the nearest tenth of a mile? So we're going to have to round off now. From Sanjeev's office to the university. So now we're looking for this s radical 3 length right here. I'm going to call that y, just so we have something to talk about there. And just recall from part A that we already found s. We already found that that was 6 miles. I mean, we could backtrack and say, oh, 2s equals 12, so s equals 6, but this saves us a little space and time since we already figured out that was 6. So now we see here that y, the thing we're looking for, corresponds to s radical 3. Since s is 6, that means that y equals 6 radical 3. But now they want this to the nearest tenth of a mile, so let's get out the calculator. So here's my calculator, plugging in 6 times the square root of 3. That's going to be 10.4 miles if we round off to the nearest tenth. For this last part of the problem, based on the diagram, they want the difference to the nearest tenth of a mile, so we're going to have to use the calculator, between the distance that Sanjeev drives home and the distance that Nancy drives home. So basically we need 12 minus whatever this other side is. And I'm going to call this other side A, just so I can refer to it as the problem goes on here. So clearly we first have to figure out what A is before we can subtract it from 12. So let's go ahead and do that. Now you could use special right triangles on this. You have a right angle right here. So if you've used up 60 here, there's 30 degrees down here, and then this is 60. You've got another 30, 60, 90 triangle that you could get the value of A from. But I didn't do that. I figure we actually already have two sides of this triangle, so I prefer to use the less complicated tool of the Pythagorean theorem. Good old A squared plus B squared equals C squared. So our A value, I'm just going to use this A for that. This is one of the non-hypotenuse legs of the triangle. So I'll square that. And then the other non-hypotenuse side is this 12 miles here. So we've got plus 12 squared equals, and now here's our hypotenuse, 8 radical 3, and we have to square that. So we've got A squared plus, this is 144. And over here, this is a little bit tricky. You could have used a calculator for the whole thing, but if you're still doing it by hand, you have to square the 8 and the radical 3 separately and then multiply them. So 8 squared is 64. Radical 3 squared is 3. 64 times 3, that's going to be 192. So careful with that one. And then if I subtract 144 from that, that's going to be 48 left over for A squared. So that means that A is going to be the square root of 48, which is, well, I don't actually care because I'm about to plug it in the calculator anyway. I'm not even going to bother simplifying the radical. We just needed to figure out some value for A and then subtract it from 12. So let's go ahead and do that to get the difference. So we've got 12 minus radical 48. That's the difference they were asking for. And now this is all calculator at this point. So here we go. 12 minus radical 48 gives us, drum roll please, 5.1 if we round off to the nearest tenth. So that's 5.1 miles difference.